que la otra mate que es cálculo, o sea, en realidad, ¿qué tipo de matemáticas es esa? No es cálculo.
Sigue teniendo derivadas integrales, pero con menos que cálculo. Según parte viene de aplicaciones
Okay. One more thing about the quizzes. I graded your quizzes, the ones that did the quiz on Friday. You were better than the other groups, that's a given. But still, half the group hasn't done the quiz yet. So for the one that didn't do the quiz on Friday, it will be tomorrow. Tomorrow at 3.
¿En dónde?
Where? No.
En parejas.
In the same class with tutoring. Okay? Entonces mañana vas a voy a hacer todo
¿Y los trae, profe? ¿Y en la calificación? Ah, ¿ya está?
Can't see only one.
No puede ser.
Fine. Ready? Ready?
Yes.
Okay. The next topic, it's very easy compared to the last one. Okay? So, this topic is a continuation of the continuity topic. Remember continuity? About jump discontinuity and all that? This is the continuation of that, producing derivatives. So it's not that complicated, it's very easy. But, the explanation then, what differentiability? Sometimes when you have a function, any function, sometimes that function is not differentiable at certain values of the domain. What do I mean by this? In that, for example, you can find the derivative of any function, yeah, but if you want to evaluate the derivative in certain points of the function, sometimes that is not possible. Okay? To prove that, we need to have certain conditions. For a function to be completely differentiable means that you can find the derivative at the value x equal to c. The function has to exist. The function has to have a value at x equal to c. Second, it has to be continuous. So we're going to check what we did last partial, continuity. And the last part is that it has to be smooth. You know what smooth is, right? Smooth is as in... yeah, something like that. It means no corners or no kinks in the graph. What's a kink? I'll show you with a graph, okay? Okay, so let's simplify that. Okay. Can I continue? Por cierto, algunos de mis espectadores del canal dicen que si pueden bajar la voz porque no escuchan nada.
Profe, hacemos mucho grabando.
Los subs, profe.
Yo sé que sí.
Ok, ya como
Un saludo a los subs, profe.
Va a ser como...
Profe, ya sin entonces, ¿cómo?
Todo raro.
Es famoso.
Si quieres.
Profe, ya también le paga YouTube. ¿Quién lo recibió, profe?
Okay, fine. Examples. For example, imagine we have a graph, a function that is like this. This function is f of x. and you have a certain value C. At that point here, this point here. This one here is f of C. Now the question is, at that specific point, is that function continuous?
Yes.
Yes, it is. How do you know that?
Because there is no gap.
It is smooth and it is continuous.
No. But first continuity. So in this case, it's continuous, yet there are no discontinuities. There are no jumps, there are no gaps, there are no asymptotes. Okay, so this function at this value is continuous. Now, the second thing, is it smooth? Yes, it is. Because it's just graph like that. There are no corners or kinks, something like that. So when that happens, when it's smooth like that, we can find the derivative of the function and evaluate at that point. It means that it's differentiable. I repeat, differentiable means that if I find the derivative of this function and I evaluate at that value, it exists and there's no problem. Okay? We'll do it. Next example. Let's say we have a graph that is like this. Here, for this function at the value C, is this function continuous at that point?
No.
Why not?
Because there's a jump.
There's a jump, yes. So, not continuous. So, that condition is not there. It's not right in that function. So, if it's not continuous, we can just say it's not differential. Okay? There's no way to find the derivative and evaluate at that point for this function. So, it's not differential. And the last example, let's say we have something like this. Exactly. That graph there, that function.
¿Es una aquí?
No, a corner. In this case, for example, is this function continuous?
Yes.
Yes, it is. It is continuous. Because there are no jumps, no gaps, no asymptotes. But the problem is that it's not differentiable.
What is the case when you have
Because in this case, here we have a corner.
There's no point there.
Mathematically speaking, when you have a corner, if you want to get the derivative, for example, the derivative of this function from the left and from the right, and you evaluate, you'll have different values. Why? Because in this case, for example, remember, the derivative is the slope of the tangent line. If I were to evaluate what happens before and after, then they will be different. That also happens when you have a kink. What's a kink? A kink, for example, is when you have something like this. A curve, and then something like that. A sharp turn. O sea, un cambio repentino. No está suave la gráfica. Okay, so this one here. Okay. Same situation. The derivatives are different from the left and the right. Okay, so Cus, sono sapore legale. Cus. C-U-S-P. Okay? Fine. Questions? Now, this is just to simplify what is the functional differential, okay? But we're not going to graph in this topic, okay? We're not going to graph. Just to see what happens. We're going to analyze what happens with variables and numbers, okay? Fine. Can I erase this?
Yes.
This part? Yeah?
Ya no me gustó esto.
Oh, rayos.
Rayos. Pero no era por ti. Sí me va a madrear. Sí me gana. Y también dice rayos.
Okay. Fine, an example then. In this case, what is this? Remember? Piecewise function. It's a piecewise function. 4 different pieces now in this time. Okay? The idea is to check if this function is differentiable at the step points. Before I continue, remember about the step points?
Yes.
The value domain. So the 0, the 1, and the 4. So we need to check for differentiability at those 3 values. But for that, before for differentiability, sorry, we need to check continuity. So we're going to do the same as we did last partial. Check continuity and then check for differentiability.
Para ahí hay que graficar, ¿o no?
No, we won't worry.
Pero pon atención. Por estar diciendo rayos.
Rayos, no rayos. Rayos.
Pero yo no puedo decir rayos.
A ver.
Rayos.
Okay. Remember what were the conditions for continuity of a function?
No.
No? Okay. For continuity, yeah. Exactly. We check the limit as x approaches, let's say the value c from the left of the function
And also from the right.
has to be equal to the limit as x approaches c from the right of the function. So the full limit
It has to be.
is the same. And lastly, has to be equal to the function evaluated at c. Those were the conditions for a function to be continuous.
Yeah, right.
Limit from the left equal to the limit from the right equal to the full limit equal to the function evaluated at c. And for differentiability, after we know that the function is continuous because it complies with these conditions, to check for differentiability, the procedure is almost the same. Will be the limit as x approaches c from the left, but not f of x, will be f prime of x. The derivative of the function. Not that complicated. X approaches c from the right of the derivative, the function, derivative, and the derivative evaluated at c.
¿No
Okay?
hay invierno de esto?
Ah,
No hay invierno, ¿verdad?
no. Okay. So, we're going to check both things. Listen. We're going to check both things for every step point in the function. So, for example, here, first with the 0, x equal to 0. First, continuity.
Oh my god.
Condition number 1, the limit as x approaches what? 0 from the left. Limit x approaches 0 from the right. Limit x approaches 0 and f of 0. Okay? Remember what to do when you have that?
Yes. And then you take the function.
Okay? Exactly. If it's 0 from the left, which function do I need to choose?
The first.
The first one because it's from the left. So it's 1 minus x squared and so on. 1. If it's from the right,
The second one, right?
the second one, so 0 plus 1, again 1, What is the full limit? What do I put here?
La que
F of x. Just the name. F of x.
sí, es uno.
And in this case, 1. And for f of 0, I need to evaluate with the series included, which is in which one? The second one. So it's 0 to the square plus 1 is equal to 1. That means that that function is what? Continuous at x equal to 0. Okay. We have proven the continuity. If it's continuous, then we need to check for differentiability.
And when I do this,
Ajá.
Solo si es continuo, ¿no?
Only if it's continuous. We'll check with all ones.
se hace nada más con el, porque tienes varios step points.
Yeah. Right now I'm just doing with 0. Then with 1. Then with 4. Yeah. Yeah. I'm going to give you this exam. You need to fill the functions.
Se cayó.
Yo estoy enamorada de ellos.
Oye, ¿sí te quieres poner ese cacahuate?
Lo sabes. No me acuerdo.
Okay. Now, for differentiability, it's the derivative. A derivative of what? Of the one that I chose at the beginning. For example, in this case, if this function is this, now for this one is going to be the derivative. So, 1 plus x squared, derivative. And then evaluate. Minus 2 times 0, 0. Then x squared plus 1, derivative. 0. Here, what do I need to put?
F of
F
x.
of prime of x. 0, 0, 0. Then f prime of 0 is the derivative of the function that I used to evaluate,
2x.
evaluated at 0. So, in this case, for example, the function that I used was x squared plus 1. So the one I need to use in this one is 2x. So it's going to be 2 times 0 equal to 0. So all of them are equal. The conclusion is that it is differentiable.
If they are not equal, it's not differentiable.
Aha.
Okay.
We'll see all cases, okay? For all of them. So in this case, at x equal to 0, the function is continuous and differentiable. It means that between this graph and the other one, the graph should be something like this. Okay, questions? Okay, now we're going to do the same with one. Yeah.
The third one of differentiability was 62.
Here? Nothing. It's the derivative of f of x. It's f prime of x. And then we check Yeah. This one? In this one, for example, when it was f of 0, not derivative, just f of 0, I need to choose the function where the zero is included, which is the second one, right? And I evaluate there. So I use this one, evaluate, and obtain one. For that one, I'm going to find the derivative of that function, the one that I used to evaluate, and I find the derivative and I evaluate the 0 there. Okay, so everything here depends on that. Yeah. Can I, no, can I erase this? Now with one.
Por andar bien. Lo tuyo también, todo en euros. Está enamorada, Pau está enamorada.
¿De quién está enamorada?
De Joshua Basayo.
Profe, no más. O sea, vas a hacerlo en cada
What's the point?
¿Quién?
¿Quién?
Yeah.
¿De qué hablas?
Desde primero, Rodri, no manches. Está muy chiquita para ti, Rodri.
Yeah. Okay. Now with one. Now with one. Okay. X approaches 1 from the left for the continuity part. Which part do I choose?
X squared plus 1.
X squared plus 1. Yeah. So 1 to the square plus 1 equal to 2. Second one, from the right of 1.
Square root of x plus 1.
So square root of 1, 1 plus 1, 2. Here, what do I do?
F of X.
F of X, so it's going to be 2. And F of 1, which function do I need to choose?
X squared plus 1.
X squared plus 1. You can just put it there below it so you can see what happens. So 1 to the square plus 1 equal to 2. Conclusion?
It is continuous.
Continuous at x equal to 1. So it is continuous. We need to check differentiability. Limit x approaches 1 from the left for differentiability. What do I do? The derivative. 2x. 2 times 1? 2. Next one. This is the function. The derivative is? Do you know why?
Yes.
Do you want to explain?
No, Ah, pues sí, ¿verdad?
Remember that this function is actually x to the 1/2 plus 1. Derivative. You find the derivative. So it's what? Derivative of this 1/2 x to the minus 1/2 and the derivative of 1 is 0.
Oh my god.
So I will write into this, which is this.
Oh my god.
Okay, there's no chain rule involved here. It's a simple power rule. So
Oh my god.
equal to what? 1/2. Here f prime of x is equal to, doesn't exist, yeah, because they're different. And f prime of 1 is, what function do I need to use? 2x, the derivative of x squared plus 1. So 2 times 1?
So
2.
it's not differentiable.
All of them, well, these two are different, doesn't exist, so we can say that it's not differentiable.
Y entonces ya la dejamos.
Yeah.
Ya no continúas.
Yeah, there's nothing to continue for that. For x equals to 1, that's it.
Y ahora tienes que seguir haciendo
Yeah. In this case, for differentiability, listen, there are no types of differentiability. It's not differentiable and that's it. And continuity, there are types of discontinuities, remember? But for this, it's not differentiable and that's it. No subtypes for that. Questions?
No.
Okay.
Está padre. Es como combinar.
Yeah. Now the last one, the 4. Por el way.
Pero ya no lo tendremos que hacer, ¿verdad?
What?
El for.
Oh, yeah.
Ah, es por cada una.
Yes. Yeah. We know that at 0 is continuous and differentiable, and 1 is continuous but not differentiable, and then we'll see what happens at 4. Yeah.
Y vamos a tener que hacer todo el proceso, aunque o sea, veamos que no es por pasillos.
Yeah.
¿Todo? Pero, profe, entonces, ¿cómo? Sí.
Pero de nada te va a servir.
Ajá, o sea, toda la función de allí no es diferenciable. Differentiable.
No, o sea.
The values are different, they are independent.
Ajá. Entonces son diferentes.
The 0 is continuous and differentiable. This one is continuous but not differentiable. We need to go into 4.
Porque entonces. The whole table no es differentiable. Que toda la graph no es differentiable.
No. So we won't conclude for the entire graph. No, the idea is to conclude for every point. Okay. Can I erase this part? Okay, listen. A ver, por los que preguntan, o sea, todos los procesos iban a todo el proceso. ¿Por qué? Porque yo les voy a dar esto en el examen. Si ya este sí va a venir en el examen tal cual, con todo y valores, no más llenarlo. Pero pues si va a venir, tienen que hacerlo. Obviamente.
Y va a poner, seguro va a poner sus derivadas bien chidas allá. Oh, van a venir así tremendonas.
Perhaps I could add a trigonometric function or an exponential or logarithmic, but it's the same thing. No chain rule, we don't think it will do Okay. Fine. Can I continue? Okay. Now with 4. Continuity. 4 from the left. Which one do I choose?
Square root of x plus 1.
Huh? Evaluate. So square root of 4 is 2 plus 1? 3. 4 from the right?
1 over x.
1 over x.
1, 4.
So it's 1, 4. Here?
No
F of
existe.
x. F of x. F of x doesn't exist. F of 4 where? Here. 3. Square root of 4 plus 1 equal to 3. Conclusion.
Not continuous.
That discontinuity.
Jump.
Jump discontinuity.
Yes.
Remember, just specify the type.
Ya nos sacamos todo lo demás.
Sí, porque tienes que llenarlo en el examen.
No, pero si no es continuo, no puede. ¿O sí puede?
Now, in this case, since the function is not continuous at 4, then yeah, no need to do this.
Ah, ¿verdad?
Tenía razón la novia de George.
Need to conclude. No differentiable.
Aparte, pues está grabando. Le vamos a pasar el video a Joshua para ver.
A YouTube.
Saludos, Joshua.
Please. Yeah.
Yo tengo una duda en la que en las dos, o sea, al evaluar con 1 y evaluar con 4, cuando evalúas el índice, o sea, de 4 de los dos lados, usas este de si yo lo entendí, o sea, ¿por qué no usas una de las que en la que sí está, pero dentro del tipo ahí?
Okay. When you check it from the left, for example, in this one, is you check the domain. Before the 4, that's my function. So I need to use this one. When it's from the right, you choose the one that is after the 4, which is this one. But here, I'm gonna choose one or the other because remember that when you don't have a little sign here, it means that it's from both sides at the same time. So which one do I choose? This one or that one? We don't know. So that's why we put the name of the function. The name is f of x. That's always the case. When you have piecewise function, if the function is something like this, you put f of x. And to find it, to evaluate, then you check this different than this, then the full limit doesn't exist. Same situation as with this one, but this one depends on the derivatives. Check this, they are different, it doesn't exist. Okay. Questions on this?
Entonces en el examen nada más le tachamos.
If it's not continuous, you cross it and tell me it's not differentiable. That's it. Yeah. This one? They are one. They are different. Okay.
Profe, ¿puede decir nuestras calificaciones?
No. Good. Can I rest?
Profe, le tenemos que poner de que jump is continuity.
Tal vez por resaltar. Yeah, listen. Listen. If the function is not continuous, specify the type of discontinuity. Yeah? In this case, it's jump because the lateral limits exist, but they are different. If you have an infinity, it's infinity. It doesn't exist in the domain. Remember that. You need to specify also that. Fine. Can I erase?
Yes.
Can I erase this?
¿Es la actividad de mañana?
Can I erase this?
Yes.
Okay. Listen. I need a volunteer. Who wants to pass? Volunteers or actions?
Elija pajarito, pajarito es mi.
Pajarito.
Ya pues, yo.
Es famoso.
Que te llegue alguien, pajarito. Dile a alguien.
A ver, yo ya vente, güey. Para que saludes a los subs.
Okay.
Saludos a todos mis subs.
Number 5. Number 5. Final.
Venga,
Ya está ahí. A ver, yo hago la de acá y tú haces la de acá.
Hay otro como.
Para poder hacerlo de acá, tiene que hacer primero esta, pajarito.
Tiene que ser primero esta.
Ya, fine.
Ah, es solo del uno. Chécale en el uno, ¿no? Sí,
Ya.
Más del uno, güey.
Ah, ya. Ah, no. Sí, yo hago esta. Es X cuadrado. Y luego de aquí esto quiere decir que es 2.
Yeah. Minus 3.
Pero no hay X. Por favor, dejen su like.
Okay.
Profe, ¿por qué fue menos 3?
¿Sí está bien? Sí. Ok.
Ahí está, yo ya.
Muy bien, pajaron.
Permítame.
Pay attention. The first one, number 5. Is it correct, x squared? Yes, it's correct. So it's 1. 1 from the right. 4 minus 3x, is that correct? Yes. Yes. Is it 1? Yes. 1 from both sides?
No.
Wrong. Okay. I told you, listen. If it's both sides the same time, the full limit is f of x. Always f of x.
Yes, sorry.
It's 1. Then f of 1, he chose 4 minus 3 times 1. Is that correct?
Yes.
It's 1. So it's continuous or not?
Yes.
X equal to 1. Okay. This.
Estoy mal en la última.
Is that correct?
Yes.
Yes. 2 times 1, 2. Is that correct?
Yes.
A ver.
No, porque es menos.
Okay. Is it minus 3?
Yes.
Yes. So, if it's minus 3, the derivative of this, that's fine. And if it's minus 3, there's no x. It doesn't matter. The answer is the same. That's okay. F from x, is that okay? Yes. Doesn't exist? Yes. Is that correct? No. It's not. Why not?
Porque no saqué el prime.
Yeah. The function is 4 minus 3x, so the derivative is minus 3. And the answer is minus 3. So it's not differential. Good. Questions? Tomorrow, we need activity, please. And do this survey. Have a nice day.